Yeah, go on, Sushma.
Yeah, so okay. So this is all about understanding the design patterns, right? So it would be really great if we just get to know what are all the real-time examples and what are all the best practices and which pattern should be able to choose which pattern should match the real-time scenarios like that. So that's one of my, I'm expecting that as a key takeaway.
Yeah, okay, great. Yeah, we'll try our best to make that possible. Yeah. Okay. So some of the few rules, won't say rules, but yeah, some of the basic things that we follow in the Zoom sessions are, if you have any question that can't be postponed, if that can be postponed, then please paste in the doc. If you are not understanding anything, then just raise the hand like Sushma, and we will try our best to convey. And apart from that if we're asking you that whether you are understanding or not, maybe you can use the Zoom reactions to indicate. Yeah. That's it. Okay, let's start. Let me know when my so sorry, I just got dropped off. Is my screen visible?
Yes.
Yes. Okay, great. I will be sharing this doc link with all of you, so as you can paste questions in here. Okay. Yeah. So today we are going to discuss practical perspective of design patterns. Okay. With this, you will be able to understand that how we can refactor or how we can write the code that is clean and follow certain principles, so that in future it's our code base that may become really huge is maintainable and can be understood by other people. And yeah, so let's start with the thing. I hope you all have some ID, maybe IntelliJ or Eclipse, or maybe a notepad also works. Yeah. So we have a requirement. Okay. As a pizza owner, you want to introduce more pizza in your store. Depending upon the input from the customer, we will give them the pizza. Okay. So I have a class here. I have a rough class here, order pizza, and here I am instantiating this pizza class, and I'm preparing it, and I'm baking it, I'm cutting it, and then returning the pizza at the end. So can anyone tell that how should I fulfill this requirement? How I can introduce more pizza in this store?
With the help of inheritance, if I can make a pizza as an abstract class and provide a multiple implementations of it, like extending, and that will have different types of pizzas.
Yeah, yeah, that's one way. Any other way?
There is an answer in the chat.
Okay, in the chat. Yes, using factory. Yeah. So people are well advanced. I think they know everything. Okay. Okay. So yeah. So the rough way will be, what you can do is just introduce type, and use if else. If the type is cheese, then return the new cheese pizza. If it's Greek, then Greek pizza. If pepperoni, then pepperoni pizza. Okay. Now I did this way. Okay. Now suppose our next requirement is, since taste of people is changing, you haven't been selling many Greek pizzas. Instead, you decide to add veggie pizza. So can people tell me how in this code base I should achieve that? I don't want Greek pizza in my menu now. Instead, I want to add veggie pizza. Switch case, yeah. Okay. So basic thing, what you will have to do, even while using switch case or if else, basic thing in this code base, what you have to do. Remain the interface, yeah, mapping, cool. Okay. Any other way to achieve simplest one? What it could be? Cool. Let me go ahead. Okay. The simplest one would be I will just remove these lines, and what can I do is I will add this veggie pizza instead. This will be my simplest thing to do. Okay. Now, can people tell like what are the issues with this code? Should I be doing this way or not doing this way?
I think it violates open close principle.
Yeah, great. Okay. Other people?
It may include some complexity also, right? Because adding more lots of if else, and then as well as like, see, for example, now we are removing the Greek, but what if in future we may also get the Greek pizza? So again, we need to add it like that. The extensive scalability.
Yeah, yeah. Okay. So this is what I was expecting from the audience. Okay. So for people who haven't understand, so what is happening here? We are open close principle as mentioned by, and don't know the name, sorry. Yeah. So it is violating open close principle. It is nothing but, that means our code should be open for extensions but closed for modifications. But at present, what we are doing in our code is we are modifying our code, we are changing it, right? And also it, as mentioned by the other participant, that it is not extensible also. So it is violating open close principle. It is not extensible in the way, suppose next time you want to add some other olive pizza or something else, peri peri pizza or some other. Okay, this class will go on increasing. You have n number of pizzas with you, and we obviously don't want that, right? And another anything else you think of there is a problem in this, apart from the big class and open close principles? What one thing you, okay, there are some things in the chat as well. Refactoring, yeah, refactoring code will be difficult. It should be config driven rather than changing in the code, move it out of the implementation file. Yeah, makes sense. So the code is basically now tight coupled, as somebody as Nagarajan pointed out, that move it out of the implementation file. Okay. So it is tight coupled. The implementation is tightly coupled with the other operations. So we why I'm saying it is tight coupled? Can anyone tell me?
Because like ordering the pizza has got nothing to do with the getting the instance of pizza. So it is actually a violation of single responsibility as well. Like ordering pizza shouldn't have the responsibility to instantiate as well.
Okay. So you are saying that creating an instance is making it tight coupled, right?
Right.
Okay. Okay. Cool. So one thing is whenever we are using this new keyword or whenever there are some things which are changing and you are writing it in the same class with the things which are not changing, like process of preparing the pizza, process of baking, cutting, boxing, it will remain same, but the process of creating an instance may change time to time. Okay, so that's why what we are opening the doors for the bugs if we are like keeping the code which is changing as well as the code which is not changing. So now creating the instance, this code can change. Okay, and that's why it is this code is the problem. So we should probably be moving this code out of here. Now I will move to next slide. Yeah. So it violates open close principle and it's tight coupled as well as we are programming to implementation. Can anyone tell what I meant when I say programming to implementation? It's doing more than what it
Like,
should be. Yeah.
like, is it like we are specifically dealing with the multiple implementations of pizza rather than that we should be simply concerned about pizza only, not like what it actually carries?
Can you please come once again?
Like I was saying, like order pizza is actually, dealing with the multiple implementations like new cheese pizza, new pepperoni pizza. But ideally, it should be like it should only have the instance of pizza and then pizza dot all the methods. So it shouldn't be concerned about what are the different implementation that we do have for the pizza.
It's like the
Okay.
different choices that people have when they order pizza. It's like it's considering every of that in that if else statement that was mentioned in the previous slide.
Okay. Anyone else? I don't want that some of the people understand everything and some goes blank. So if you have any questions, please feel free to ask. There is no silly questions here. Session is more for the people who don't know, obviously. So you can ask questions.
Hello, Gunjan, Jay here.
Yeah.
So can you tell a bit more on tight coupling? What is it actually does?
Okay. Okay. Great. Let's move back here. Okay. So when we say code is tight coupled, that means one thing is dependent upon others. Okay. So here what we are doing is we are creating the different types of instances as well as we are performing different operations on these instances. So what is happening? These creation of instances and the operations, although they are not related to each other, but they are kind of coupled together, tightly coupled together. So say suppose I made some changes in cheese pizza class. Say now it also accept some toppings. Okay, what toppings I want to add on my pizza. Okay. So while creating a stance, I will make the modification in this class also, order pizza class. Although our process of baking or cutting is not related to this, right? So I am unnecessarily introducing the bug in my entire thing. There are high chances that the bugs can be introduced. So whenever we change the code which is not required to be changed, it it is the door for the bugs are open. Jay, are you clear or like not?
Yeah, sure. So the implementation of it and then the creation of the object. So
Okay.
that made it.
Okay.
Thanks.
Bit unclear on the term. Nagarajan, which term you are saying about?
He mentioned it before, the tightly coupled. I think that's
Okay. We need to keep modifying our code every time there is new pizza type introduced. Okay, program to implementation. Yeah, yeah. Okay, cool. So program to implementation. Yeah. So we can see here that we have used this new keyword and we are using concrete classes here, right? Now, if we are using concrete classes, then we are programming to implementation. That means because these are the concrete implementation of how the pizza is made. Okay, and whenever we program to implementation, it reduces reduces loose coupling and it increase tight coupling. In the way, suppose as I explained tight coupling, suppose tomorrow you went on to change the implementation of cheese pizza. Okay, it will also affect this order pizza class because you are programming to implementation. Now I would want people to tell me, instead of programming to implementation, what should I do?
Simply use a factory here to get the pizza instance, and then pizza dot prepare, bake, cut, box, and
Yeah, other please. Okay, program to interface. Okay, programming to abstractions, interface or abstract classes. Uh, Nagarajan, are you clear with this? Since you, okay. Okay. So programming to abstractions, how it will help us? Can anyone please tell me? I'm not aware of since.
Using abstractions, we can, hide the like immediate details of how we are implementing or creating a cheese pizza or veggie pizza. In that sense, we can in future change the way we are making the cheese pizza, but the order pizza will still retain the same, the methods and all. But the
Yeah.
internally, we can have much more, freedom to make our changes.
Yeah, very well said. Anyone else want to add something? Or wants to ask something? Delegation. Okay. Nagarajan, can you explain a bit more about this? Like what you are exactly saying? Or maybe Divya, would you like to add something to it?
Yeah, Gunjan. So this basically like modifying this will help us to adhere our code to solid principles, right? So one is we can introduce loose coupling. So we don't, and one more thing is, bringing open closed principle. So we don't have to change order pizza code in order to introduce a new type of pizza, or even if we are modifying the existing type of pizza, right? We don't have to change this code in order to, change the actual implementation, right? So all we have to do is plug some changes in the factory and everything will work as is. And it will not break any test cases and all. Yeah.
Yeah. Okay. We understood that it will introduce loose coupling, it will reduce tight coupling. So do people even know like why do we want to reduce tight coupling? Why is it not good to have a tight coupled code?
Scalability.
like cascading effect, making change at one place will like uh, enforce change in some other place. So which shouldn't be the case all the time.
Okay. Anyone else wants to add something? Maintenance tool. Scalability. Yeah. Also help in segregating responsibility of creating pizza, interdependence between different modules of code. Great. Um, cool. I think we are good here. If people have any more questions till this point, please feel free to ask. Or write in the doc that I shared. Abita, can you please check if there are any questions here in the doc?
No, Gunjan, I didn't. There is nothing about that.
Cool. Okay. So we got to know that we should instead program to instead of implementation. Okay. So as I will just reiterate, mostly you all have given me the answers that I was expecting. So I will just reiterate once again, like why we should program to interfaces rather than the implementations. So we shouldn't program to implementation. We should program to interfaces in order to keep loosely coupled. Okay, as you all suggested. Since if the implementation changes, it won't be affected. So next time, if I want to add some other class, instead of adding the concrete class to my code, that is new cheese pizza, if I would be having interfaces, then it means it will reduce tight coupling, right? I can freely add new classes as number of classes as I want and simply implement the interface and I'm good. Now, can people tell like, should I move this? What should I do with this code? One more, it helps in making code testable. Yeah, the way you are right. So did people understood like how does it make the code testable? Or the way would you like to explain?
Yeah, sure, Gunjan. So basically, let's say we want to write some test cases to this order pizza method, right? And let's say like it also requires to connect to database or some other third party, right? So at that point of time, so if we have these kind of concrete implementations, which means we are instantiating the objects inside this order pizza right away. So we will not be able to, inject the mock into this. So which means our code has to connect to the database or other the third party tools in order to execute even for the unit testing part, right? So ideally it violates the unit testing principles, because unit testing it has to test only the piece of code which we are trying to test, and it should not connect to any other third party tools, right? So if we are having interfaces or implementation based on interfaces, right, what we can do is we can easily inject the mock of the probably the database or the third party APIs. So we can just mark those APIs and we can execute this code so that only this part of code will be executed and tested. It will not connect to any other third party apps. So yeah.
Cool. Is everyone clear with this? Or okay, Baba was clear. Anyone else? Any questions? Or should I move ahead? Can please people give thumbs up if it's good? Cool. Yeah. So we were on the point that how should I program to interfaces rather than the implementation? So some of you were suggesting that let's create a pizza interface and then just all other pizza should implement that pizza interface and let's do that. Yes, cool. Okay. So what should I exactly do with this code? Can just one of you explain me? Like
like removing this entire if else if ladder with a single statement that will return an instance of pizza.
Okay. Is everyone fine with this? Okay, let's now see how exactly we can do this. Okay. Yeah. As everyone suggested me, like keep a pizza abstract class. Okay. And this pizza abstract class will be having the functions, or you can say for preparing, for baking, for cutting, for boxing and everything. And we will have our cheese pizzas or different types of pizza extending this class in order to have a specific functionality. So what we did exactly that only. We are extending the pizzas and we have a pepperoni and we have veggie and simply that. Okay. So now as Weber said that let's just replace this entire if else with a single line code. So exactly this what we are doing is, what we did is, let me show you. Yeah. So earlier we were having this type of code, right? Now what we have done, we have simply extracted entire creation of pizzas in one class, and other code is still there. And we are just using the composition here in order to have our factory so that we can create different types of pizzas. Okay. Is anyone having any questions? Okay. Pizza factory dot create type. Yeah. To start with, we can just move the if else to separate static method. Yeah, that also works. So if you are not doing anything like state tracking or something, you can simply move the entire code to static method instead. I didn't do this because there may be a possibility that you may further want to extend the pizza factory. In case of static methods, you won't be able to do that since we can't extend static methods. Are people having any questions? Or should I be doing some other way? Any suggestions? And yeah, sorry.
No, good.
Yeah, Jyoti, go ahead.
Yeah, so there was we were discussing about single responsibility, right? Now
Mhm.
the pizza store is a kind of a god class which is carrying all the responsibility of creating, preparing, baking things. So any suggestion like anything we can do better over here?
You mean that pizza store class is having entire responsibilities, is it?
Exactly. Yeah.
So if you exactly see in this class, uh, although we are having these methods calls from here, but we are not doing exactly entire thing in this class itself.
Mm.
Okay. So we have outsourced our create pizza thing. We have outsourced our prepare thing, and they are completely flexible to change. Even if I go on to change this create pizza implementation, suppose one day, then it won't affect my pizza store in any way.
Hmm. Yeah,
Right?
which is fine. I mean, let's say we delegate the responsibility of creation, preparing to pizza entity itself.
Yeah.
So,
So yeah.
hmm. So pizza also carry these responsibilities of doing multiple things. So yeah. Did you get my question?
I think her internet is kind of
Ah,
like
okay.
she's stuck.
Abita, do you want to take that question? Should we wait for Gunjan?
Yeah, I think probably you should wait for Gunjan.
So we can probably use this time to add any questions you have in the doc that Abita or Gunjan shared.
Extremely sorry. Just yeah. Jyoti, can you repeat your question?
Yeah. So I got your point. Like that was a kind of a client, we can say, to do something with the pizzas,
Yeah.
maybe creation, baking things. But if we talk about pizza class, right, it's carrying multiple responsibility. That I was thinking, like, let's say we talk about single responsibility, but now this class carry multiple responsibilities.
Okay.
Yeah.
Yeah. So if there are like two ways to proceed, see this. Uh, at first, can you just tell me like what exactly is meant by the class?
I mean, class is any entity, real time, uh, any noun we can say, which have some behavior
Mm-hmm.
and it have some state where you are doing some state updations. Yeah.
Okay. So see, one way to see is we have some attributes of okay, and we are having some behavior associated with this pizza class. This prepare, bake, and cut, or maybe box is having. You can say these are the operations that we are performing, right? And another way to say is like you said that it is violating single responsibility principle. I also agree with this. So say on if we have different types of ways to prepare these pizzas. Obviously, you can also extract this from here and keep it in some other class. Okay, maybe use composition here in order to get this preparation methods, and similar goes for baking. But for now, we have kept this simple, so there was no need. That's it. That's it. If yeah, just for the example purpose, yeah, obviously, if you go on creating entire pizza store, suppose in real, then you can think of the ways, and so that if there are different ways of preparation, then yeah, extract from this class. Don't keep it from this class.
Okay.
Basically, like class can contain multiple behaviors, right? Like what we are doing here, like we have different behaviors, like the bake, cut, box are the behaviors of the pizza class. So that is not like we could say that is not violating the single responsibility principle there because it's a behavior of the class. We can we should be viewing it that way.
Yeah. Are we clear, Jyoti?
Yeah.
Cool. In factory also there are different letter. How can that be in my opinion? Single. Yeah, you're right, Pulkit. Okay. Akshay is saying, and even in the simple factory class, we have if it's letter. How can that be further optimized? Okay, you are right, Akshay. We will come to this later on in the session. So you have to wait.
Just to add on, like I agree, like single responsibility, we can't distribute multiple behavior on different class. Could that be a right way? Let's say I'll create a class for a behavior itself. I mean,
no, you shouldn't be creating a class just for the behavior.
Like pizza creation, which is taking care of the responsibility of creation of that. So,
see, pizza creation. If you will be creating a class only for the pizza creations, if we see all these operations are related to each other, right? We are performing these things on the pizza. So creating a pizza creation class won't make sense actually.
Okay.
Yeah. Yeah, so there we have seen that how we can program to interface rather than the implementations. So now we have unveiled a pattern here called simple factory pattern. Some people take it as pattern, some not. And the thing is just that we are moving the logic, so it can't be considered as pattern. So yeah. In this pattern, client just need a class called simple factory and does not care about which concrete implementation it is getting. So we have seen a client just needs a simple factory and it does not care about which concrete implementation of the pizza it is getting. Okay. So what we are doing here is, in this we are just moving out object creation logic in the form of classes or static methods. As I said earlier, in the form of static methods also we can do, since it does not need any kind of state tracking. Okay. So what we have done is, we have just encapsulated the code which was changing. So the culprit was here change. So the code which was changing, we have encapsulated that and we have moved out. So it is a method that encapsulate object instantiation or creation. Okay. One such form of example you can have in Java is number format. Let's see how number format is.
Can you increase the font size here?
Sure. Is anyone aware of how can I do?
Command plus.
Command plus is not working.
You can just zoom into using trackpad. That would also.
Yeah, that works. Is that fine now?
Yeah, that's good.
Okay. So we have here a number format class, which is extending the format. Okay. The format is nothing but an abstract class. Okay. We have here this factory. This is the method. This is a factory method. Here, what we are doing is depending upon the different formats, we are returning our string in whichever way we want. You all can also explore this class in order to get better understanding, like how even Java is using these patterns. Let's move ahead. Yeah. So this is the basic UML diagram that we have seen of the simple factory. We have a simple pizza factory that includes create pizza. Okay. These different types of pizzas are just implementing this pizza class, and we have a client which is having order pizza, and that eventually is calling making use of this simple pizza factory. I will just pause for 1 minute so that you all can read through it and let me know if there is any question, or I can move ahead. Or please give thumbs up if it's all good.
This pizza is an abstract class, is it?
Yes, pizza is an abstract class. We'll wait for 1 more minute, and then if anyone is having any question, please raise your hand.
Can pizza class be an interface?
Can pizza, yeah, pizza class can be an interface.
Okay.
I will be moving ahead now. Okay. That. So it's all about encapsulating the object creation, or maybe the code that is changing frequently. Okay, and or maybe separating different types of codes which are changing and which are not changing so frequently, or which are not dependent. And the factory can have many different types of clients. So for now, we have just seen that we have a pizza store, but maybe for next time we have some pizza shop menu, or maybe home delivery thing that can also make use of this factory class and get the pizzas from there. Okay. That we can make use of static methods that we are doing. We are doing this, we are of this pattern as criteria. If like going on criteria.
Gunjan, are you able to hear us?
Adding, then this will also create a problem. So we should think of any other way to do this. We have multiple inheritance use case here. Yeah. So, did everyone followed what?
Hey Gunjan, can you repeat? I think my network has
Gunjan, do
been.
you want to go off video because
Yes.
your
Yeah.
voice is breaking in between and you're getting stuck?
Cool. Now it's better.
Okay.
Yeah, but you would have to repeat whatever
Yeah, sure,
you
sure.
repeat.
Yeah. So some of the inferences from this, and these are like we can encapsulate the object creation, and that or maybe the changing code from the code which is not changing, like we did. We just encapsulated the object creation part.
Faster again. Okay. We lost Gunjan. Wait for a few more minutes.
Where did I dropped off?
Gunjan, do you if Abita also has the same slides, she can share. You can just talk over the slides since you are
Yeah.
sharing. Yeah.
Yeah, works.
Abita, could you share the slide?
Yeah, sure.
Great. You could see the slides.
Yeah. So from where did I left?
Encapsulate object creation. You
Cool.
just started with that. Yeah.
Yeah. Yeah. Okay. And after that, we a factory can have many clients. Factory implementation that we have if we go on using say static methods. Now let's move over to the cones. So say criteria for creating the objects, if that gets complicated, that means we are having multiple types of pizzas. So our factory class will keep on increasing in size, as Akshay also pointed out. So we will have to find some way to improve this. Yeah. Abita, you can move to next class. So say now you have a press that create posts like, so we are over there, and now I'm just giving you a situation. Okay. And you want to design it so that it follows the pattern with
Gunjan, should we take a break now? Like your voice, like you are breaking often, so often, and not audible at all. Should we take a 15 minutes break and then we'll fix this and we can continue? Sure. So currently it's 10:56. Can we all meet at 11:10? And then we can continue. We'll meanwhile fix Gunjan's audio issues. Cool. Let's meet at sharp 11:10.
Free. say in your pizza store, you want to also start a franchise system and you want to ensure everything is perfect. So you want them to use your code only. You don't want to change them. Okay. So depending upon the regional differences, there will be also change in the taste, right? So now we want to implement that also. Can anyone tell how should I implement that? Say you have different states and now you want to introduce Delhi cheese pizza or maybe Kerala cheese pizza or maybe Himachal cheese pizza and different types of these things. So how should I go with this? You have learned something or maybe you can introduce anything new to us. So in the previous slides, we have learned simple factory. Basis that you can also tell or some other thing. If requirement isn't clear, please feel free to ask that also.
Can we have the like we have cheese pizza and pepperoni pizza like that? Can we have the Delhi pizza, like Kerala pizza or Himachal pizza, so that we can add the flavors to the particular code only? For example, in the Delhi, we will have the availability of Delhi pizza, which will have the unique taste that the people in Delhi will enjoy.
Okay. Anyone else? So you are asking me to create different types of factories. That means for Delhi, Kerala, and Himachal, is it?
Yeah.
Yeah.
As in practice, as in a different kind of, for example, we have an abstract class called a pizza, and it will, have a implementation that will implement various methods that we can have from an interface. And similarly, these flavors that we have, for example, pepperoni or any of the ingredients that we use in the pizza, they will take the pizza abstract class and they will implement the various things that are needed to bring out that a flavor. So we can then integrate all of those flavors in one place. Other place, for example, a pizza store where we are concatenating all the changes that we need to make the particular pizza.
Okay, got it. So Amya has asked some questions that can the creation class also be abstract, another layer of abstraction. Did you ask in the context of this requirement only? Can you please elaborate? Okay. So can you please suggest like how should I do this if the creation class will also be abstract? Hmm.
Hi. Hello.
Yeah, you're audible.
Yeah. Actually, here in this contest, we have two kind of abstraction. The first is based on the region. The second one is based on the case, right? So we can go for like abstract factory method. So in that, the first level, it's based on the region we can divide it. After that, each and every region we have a different kind of flavor, right? So I believe go for it.
Okay. So you want to create some abstract factory method. Thanks, Anshul.
Yes.
Okay. Is anyone else having any other idea? So one is we can create different type of factories. Okay. And another one suggested by Senthil and Amya is let's go on and create an abstract class. Yeah, let's go on and create an abstract class depending on and an abstract method basically. So anyone sees any advantage over one over the other, or maybe Amya and Senthil can explain if there is an advantage rather than creating different type of factories. Or any one of you. Okay, suppose I have created 3 factories and so 3 factory basically methods in a class. Would it be violating some principle or it's all good?
Can you elaborate on which 3 factories you are creating? Could you-
Say, suppose I have, as suggested by I think Aditi, let's say I have created Delhi factory method and Kerala factory method and Himachal factory method in a class,
Okay.
simple factory class. Would it be violating some principle? So I have unrelated code present inside the same class. I hope now it's more clear. And we really want that, right? Don't want that, sorry. So it will be violating single responsibility principle if we will create 3 different type of factories inside a factory class. So let's took up the other way out in which we will be having an abstract factory method instead, and then we will have different implementation of that factory method in order to achieve our objective. Okay. Now let's see how we can implement that.
Gunjan, I didn't catch the implementation that you were talking about. Can you
Okay.
elaborate more on that?
Yeah. So we were having 2 ways. One way was that we can create 3 factory method as we have created for the pizza, right?
Yeah.
We can have a factory method for Delhi. We can have a factory method for Kerala. We can have a simple factory for Himachal, right?
Right.
Yeah. So if we will do that, then there will be too many factories. And in fact, there will be duplication of some code as well, right? Because some of the ways might be same. And
right.
Yeah. But if we use an abstract method, okay, then we can just override that method in our subclasses and add whatever implementation we want.
Right.
Okay. And also there are other advantages as well. So suppose tomorrow your way of implementation changes. Okay. And if you are just using simple factory, then do you really think that will give us the freedom to make the changes?
No, I don't know if there is any possibility in that sense.
Yeah. So it will make the changes or maintenance complex, right?
Yeah.
And also there will be bit clutter since there will be too many things inside a class.
Okay. Yes.
Anyone else having any other questions?
I don't see any hand raised or unmuted.
Cool.
We can move.
Yeah. Now let's see that how we can really go and implement all this that we have discussed. Okay. So now what we have done is we have made this pizza store as an abstract class, and we will keep our code as it is, our order pizza code, and we will be having an abstract method called create pizza. And all our factories will be implementing this create pizza. Okay. Now let's see how it happens. So we have a Delhi pizza store, and this is also implementing this create pizza. And we have a Kerala pizza store that is this is also implementing this create pizza. And depending upon different types, we are returning the pizzas. That remains same. You have a pizza abstract class and different types of pizza that remains same. Only difference is here the way we are creating the pizza.
Gunjan, are you sharing?
Anything, yeah. So
Oh, sorry.
I can only see
I
presentation.
just forgot. I just
and
will
also
share.
let's
Sorry.
go little faster as we have to cover a lot of things. So we can
Yeah,
you can post
yeah,
your questions in the chat and then we can take those questions. Yeah.
Yeah. So here you can see we have a pizza store abstract class, and we have a abstract create pizza method. Okay. Now our pizza stores will be implementing this create pizza method in order to generate the pizzas. Instead of having a single simple factory class that will be having different simple factories related to Delhi, Himachal or Kerala, we have just introduced different subclasses so as to make this a bit more flexible for future. And also, since we have seen that there was some kind of hierarchy here, since in the creation of pizzas there were some things that were already common, like or the process of ordering the pizza that involves creation pizza, preparing and baking. These all things are common to all the pizza stores. So keeping that same, we have just differentiated the way that we create the pizzas. Okay. I hope I am clear. If not, please. This is going to form the basis of another design pattern. So if anyone is not clear, please feel free to ask question or I will move ahead. Give thumbs up if you all are good. Cool. I will yeah. So what we have seen, we have a product called pizza, and we have a concrete product like cheese pizza or maybe another type of pizza. Okay. And we have a creator that includes the factory method and the operations that are going to be performed on that our product. Okay. So our creator is this pizza store, and our factory method is this, and different types of operation that are being performed on our product are this. And then we have a concrete creator that is implementing this factory method. Pausing for a minute so that you all can go through all this. Okay, I'm moving ahead. Yeah. So inferences that we draw from here is whenever you see inheritance or there is hierarchy, then or there are any chances of adding more products, then you can follow this way. Create an abstract method and implement the subclasses. Its subclasses will decide what type of pizza will be created. Our client pizza store has no idea. So when we implemented this create pizza method in our subclasses, then only we got the concrete pizzas. Our client, that is pizza store, is having no idea related to this, that what type of pizza it is going to be. So it's all depend upon subclass. This basically decouples the implementation of product from its use, or basically the operation that we are going to perform on this. Design pattern that we have unveiled is factory method. So a factory method handles object creation and encapsulate it in a subclass. The way we have already seen that we have encapsulated the object creation in the subclass. Now, example of this is in the Java, which you can find is in abstract collection. We have an iterator method. This is nothing but a factory method, and different subclasses that are implementing this factory method are array list, linked list, and I will just quickly show that as well. So we have this abstract class method. And the different classes, let me show. Okay. So array list is having its different implementation, and some other linked list might be having its different implementation. You can explore this class in order to get the clear understanding. Let's go ahead. Okay. So pitfalls of the this method are that more classes are being involved, and sometimes going forward it might not be easy to refactor. And it also forces us to subclass just to create instances. Okay. Are we good till there? Or if anyone is having any question, please raise your hand or give thumbs up if all good. Cool. Cool, I'm moving ahead then. Yeah. So factory methods, it basically delegate object creation to subclasses and is not aware of what type of object is being created. Okay. Whereas simple factory just moves the logic and is aware of the objects being created. Factory method gives you the flexibility in way the products are created. You can change in subclasses. So when we were creating the pizzas in our subclasses, we can surely change the implementation, the way it is being implemented. Whereas the simple factory only do the encapsulation of object creation. Factory method is generally used when you have some generic processing in a class, but want to vary which kind of So in our pizza store, we have some generic processing, but we want to vary our creation of the pizza. So we did that. But whereas in simple factory is fixed in that you have just one implementation with no subclassing as such. In the okay. I hope the differences between the two is clear. So suppose you are seeing some hierarchy or some inheritance, or you think that going forward you want to add more types, as well as there is some inheritance that can be done, then use factory method, or else you can use simple factory. So now people might be thinking that eventually what we are doing is we are using this new and everything. Although I said that whenever you use the concrete classes, then it leads to like tight coupling. People have question regarding that, or you all know that eventually we have to do. Okay, I will tell you. So there is something called broken window principle. Okay, so when we follows these patterns, maybe factory pattern or simple factory pattern, then we prevent us from using violating broken window principle. So what is broken window principle? Instead of if you see a broken window, you don't break. There is tendency that another person will also come and break the window, right? So what we have, what we are doing is we are just encapsulating all this concrete class implementation so that we can maintenance could be easy. It should not be everywhere that window is broken. If one window is broken, let's just handle the fix of that. I hope I am clear. And Akshay, with this, I have also tried to answer your question that we are using FLs and everything. So eventually you have to end up using new. And there is no harm in using new if you know that going on your class won't change. Try to make the code as flexible as possible, but at the end, using Java, you have to create the object and you have to use the concrete classes. If anyone has any question, please let me know. You all are understanding, right? Or it's all blank? Please give. Okay. Akshay is good. Cool. Great. Yeah. Let's move to another. So we have another situation here. Suppose you want to create different types of messages. Say JSON message.
Just a second, Gunjan.
Yeah.
I think we have a raised hand.
Yeah. Go ahead.
Yeah, so for hi Gunjan. So in any case, we have to while the first usage in the first usage we have to create state-wise pizza creation, right? So pizza store. We have to create the instance of state-wise pizza store then.
You have to create the instances of state-wise pizza store then. Yeah, you have to. Sorry, I forgot to share this. Yeah, you have to create the instances of state-wise pizza in your driver class. Okay. And while calling this order pizza, you have to pass the type.
Can this be done in otherwise, like saying like pizza store and then passing the state to it along with the type?
Passing the state to it and along with the type. Yeah, that can also be done, but then that will be only mean that we are creating different types of factories itself. Like if I show you this pizza store, wait. Yeah, so we have this simple pizza factory. Yeah, so it will be similar to creating like this. Okay, so we will be creating, we will be passing in the pizza store, suppose say Delhi, and using if else, you will be returning the different pizza store. Okay, so what will happen eventually in the pizza store class, what you will see is like this. You are having a type, or maybe you are doing the injection by constructor and you're returning it here. So eventually you will turn it into a simple factory. It won't remain a factory method.
Yeah,
So
in in that case, we'll be just creating pizza store instance, giving it the store name. So in any case, if a new store has to be open in other state, it will be just creating a new class.
Yeah. Since there is hierarchy, right? The way we follow the things. So we have chosen this way. That also can be done if you have not many regions that are having stores, then you can follow that way also.
Yeah, thank you.
Quick time check, people, like 11:40. We still have like 1 hour and 15 minutes left. So we'll go faster, and then in the document Gunjan has shared, you can post your all the questions, and then we can like reply to that in the document itself. That also we can do.
Yeah, okay. Now coming to another situation, say you want to create different types of messages, JSON message and text message. And while fetching the message, you also want to encrypt and add default headers. You have to implement it using factory method. So for now, since we don't have time, I would just skip this and you can try it on your own now. Later on, we'll share this solution as well in the end. Let's move. Okay. So now we are coming back to, we are coming on to dependencies. Okay. So now let me show you. Yeah. So now in this dependent pizza store, can anyone tell like how many concrete class? So dependencies is nothing but we are creating concrete classes. We are programming to implementation. So can anyone tell that what we are doing, like how many number of dependencies are there?
One is related to the region.
Mm-hmm.
And another one is related to the cheese and this different type.
Okay. Cool. Now what you can see is in the pizza store, we have different types of concrete classes here. Okay. We are having Delhi cheese pizza, we are having Delhi veggie pizza and all that. We are having different types of pizzas here. Okay. So tomorrow, if you want to add another types of pizza, you will go and modify the code here and enter the things. So here you are programming to implementations, right? That's why dependency will get on added here. Now you don't want that. We don't want to like program to implementation. So what we can follow is dependency inversion principle. So let me show you like what all is dependency inversion principle. So dependency inversion principle is nothing but depend upon the abstraction, do not depend upon concrete classes. It might be sounding similar to like program to interface and not to implementation. Since here, there also we were depending upon abstraction. So it basically says high level component should not depend upon a lower component rather than depend upon the abstraction. Okay. So here, if we go back and see, we are having a pizza store that is our high level component, and we are having the pizzas that is the low level component. So high level component is the one which is performing some operation on the low level component. So low level component is our pizza. So next, say we are taking out the abstraction that is our pizza, and now our pizza store is dependent upon the abstraction that is pizza, and different types of pizzas are also depending upon the abstraction. Similar thing we have done in our factory method as well. We are having a pizza store and we are having an abstract class on which our pizza store depends. That is our high level component, and also our different pizzas also depend upon different like pizza abstract class. So now our high level component as well as low level component depends upon the abstraction rather on each other. So this also is done by factory method whenever you follow the factory method. So now we are almost reached to the end for the simple factory and factory method. So you have some guidelines here that you should try to follow. But if you are not able to follow something, then you should have good reason to break that. So say suppose we say that no variable should hold a reference to the concrete class. We should try our best that none of the variables should hold the reference to the concrete class. So here, if I go in Delhi Pizza Store, our variable is holding the reference to the concrete class, but we have a good reason, valid reason here. There are chances that there won't be any other kind of variation in this. It's not going to change. Then you can surely use new here. No class should derive from concrete class. If you're deriving from the concrete class, that means you were not depending upon the abstraction. You were creating the tight coupling here. And no method should override an implemented method of any base class. Since all other classes are also going to implement this base class, so we should try that we should not make any method in the base class, so that we have to override that, although it is having any default implementation. I think I am good with this. I'm done. If anyone is having any questions, please feel free to write in the doc and I will try to answer the questions parallelly.
I just had one doubt.
Yeah.
So here, can you go back to the code?
Okay.
So here we are segregating, I mean, like we are creating abstractions based on the details, right? So that's fine.
Mm-hmm. Yeah.
Because I think that we could have also abstracted, like we could have also made abstractions independent of the details. Then that way we could have been able to do dynamically adding the components, like.
Mm-hmm. So you are saying that in detail as in which detail you are mentioning about?
Like the Delhi cheese pizza here, this pizza is having the details for the Delhi cheese pizza. For example, tomorrow I need a New York pizza. So there I need to add more details, like the class will also have the details inside it, which will, like every time I need a new region or a variety of pizza, I need to create a new class. So I was like thinking that I could have created a component which is independent, like it is like a detail wise component. So it will be called from a higher level abstraction, which will be used by another class. So that class will be having the independent, like it will have the ability to call any type of variety that we have. Is, for example, is it a Delhi cheese pizza or a, sorry, I'll just start again. So for example, you need a Delhi cheese pizza. So I have two components for that. One is the region and one is the cheese. That is a component of the pizza.
Mm-hmm.
So in these things, we have two components. So we could have made it independent of details so that we are not showing what details are there. But in this pattern, what we will do is we will have a abstraction for the region as well as the components that or the materials that we use to create the pizza. So I was just thinking if we could have optimized in that way as well.
So optimizing in that way, then you have to pass at least inside. So eventually what you would have done is inside, while creating the instance, you would have passed this type and reason. I mean, right? Yeah.
Right.
But then it will turn out to be the same code that we saw in the early stage. Okay. Suppose say similar to this kind, right? So we have, so whatever clutter that we try to solve, it will eventually fall into that trap. You will have
actually here what I was thinking is that we could have created something like an abstraction that will add on to other abstraction. So in the final, we could add on to one another and we can concatenate it. I think I saw a pattern called decorator pattern. So they were like saying that we could have added the abstractions dynamically. So I was just thinking that way we could have done it.
There are different types of patterns, so maybe one of them that also. But for
Could we take this question to the document, and then
Yes.
maybe you can address it there, because we still have like really are running out of time.
All right, sure.
Thank you.
Abita, you can take it up.
Yeah, okay. I'll start the screen sharing. 1 minute. Yeah, I hope everyone can see the slides that I'm showing right now. Yeah. Can everyone see it?
Yes, Abita, we are seeing the requirement 1.
Okay, cool. So we'll be starting with a different pattern here, and same as how we did while Gunjan was presenting. We'll start with requirements, and with the requirements, as we go, we'll find out how to do something and then see which one it is. So first requirement is like, we want to create a user object that has like 5 attributes: first name, last name, age, phone number, and an address. So how will you do that? It's quite simple. What you will do here is create a class and user which has like 5 private attributes, and then have a constructor which takes in all these values and assign it, right? So 1 second. Yeah, it would look something like this. The constructor would be something like a user which takes in the string first name, last name, the age is an integer, phone number, and the address. And then this would be how you give all those values, right? So what if now another requirement comes up which says we only want the first name and last name as mandatory, and the rest 3 fields are optional. What will you do in this case?
We need to add required
Jaypreeti, can you come again? I couldn't get you.
we need to add required keyword for first name and last name.
Okay, so in that case, it's like the other fields. Okay, maybe we can talk about anything else that you have in mind. What is another method that you think of? And then we'll come back to that. Yeah, go ahead.
The required field can be provided in constructors, and other can be provided as a properties.
So we'll have setters for that, right?
Yeah.
Okay.
Okay. Or we can have other patterns as well, builder, like in chat. We can have builder pattern for that.
Okay, we'll come up to that, but like let's go with the simplest methods that we have to do.
Yeah.
Yeah. What would be the simplest way of doing this? Say first name and last name is mandatory in everything. The other three can happen or not. Wait, I think someone's posting something. Okay. Yeah, yeah, everyone's going in the right. Yeah. Yes, we can have a constructor. Yes, we can have multiple constructors. So then in that case, when you have multiple constructors, it would look something like, oh, wait, yeah, something like this, right? Every constructor will have the first name and last name, and then you can keep having one which has everything, and then the others which will, you can change the things and have it. So yeah, now we heard about setters and getters, right? But we know that we never it's not a good pattern method to normally use setters, because we use the mutability of the instance in that case when we have setters. And if it's an if you want to create an immutable instance, it wouldn't help, right? Yeah, so this case where you have to have multiple constructors, when you have mandatory and optional fields. This is what we call telescoping constructors problem. So if you see here, depending on the scope, we are having multiple constructors, right? So in this case where we only have like 5 fields, this is what do I say? This is manageable, right? Even if you have multiple constructors. But what if your class is something which has like 10 to 15, a lot of fields, and only a few of them are mandatory, and all the others are optional? Having a lot of constructors won't be a good idea in that case, right? So yeah, that's what our third requirement is. We add one more attribute, salary. Now what happens is that whatever we have, creating constructors as we saw earlier becomes more difficult, right? And then maintaining all of them. And in the case where most of the fields have the same data type, most of the fields have the same data type, it becomes difficult to know which one you are expecting in each of the constructors as well. So yeah, this would be like the 2 different ways. See, here we have, yeah, this might be a few of the different constructors you have. There can be a lot more. I have only added a few here. So what can you do in this case? How can you make it so that we always have the first name and last name, but the others can be something which we add, but obviously not setters, because it can affect the immutability of our instance. So this is when we'll talk about something where we have another class which would help us in creating this whole user. And what the class would do is, that would take in all the different fields we need, and then we will have a method there which will then create the user and then return it to us. So if you go with something like that, our code will change, and it would be something like, okay, yes. So whatever we have here, we wouldn't have all these constructors. So first change would be that we won't have any of these constructors. We'll start with how we have the other class, or the helper class that we used to build this user. So we'll call that class user builder, and we'll be talking about the way where we have the builder class inside our main class. So inside the user. So it would be an inner static class, and so it would be something like this. Bleeds class user builder. So we'll have something like this. And this one also has all these fields, which would be what we have here. So something, this would take in all these values. And then user builder would have a constructor which would have taken both the first name and last name, or all the mandatory fields would go into this builder class. So then it would look like something like this. Yes. So this is how the builder class would look like. And now, okay, now we know that we get the return of this one whenever we use a constructor, we get a user builder itself, right? So we are making use of these two here. Yeah, another change that we probably usually make is we'll make these private final actually. And one more minute. Yeah, so we'll have the first name and last name here, which would be what then the builder would make use of. And then depending on whether we need the other, it depends on, right? So we'll have separate methods which would create these fields. So say we, okay, before we move to that, we'll also be making use of something called method chaining here. Anyone here who needs more idea of what method chaining is? Okay. Okay. I hope then everyone knows what method chaining is, and I'll move ahead with this. So what we'll do is, method chaining, what we normally do in is, the methods usually will be returning the class, an instance itself. And so we'll keep on having a chain of methods. So I'll write one method which would add the age to it. So something would be something like public user builder age of, pass the value here. And then what you do here is you add the age here to this, and then return the user builder that you are already creating. So you will have something similar for address and phone as well. So for address and phone as well, what you will do is have a thing similar to this, and then you will return in the same way. So it would look like this. Oh, okay. And the other one is phone. Now, earlier, yeah. Oh, okay. Okay. Yeah, I'll give more clarity on what method chaining is. So method chaining is when, okay, wait, I'll show it to you here. So earlier, in case where we were creating user like this, so method chaining actually helps us to do something like this. So say, okay, yeah. Simply giving values right now. So method chaining actually helps us to do something like this. So you can pass, this is one, this, will return as a user builder because it's a constructor. And method chaining, what it allows us to do is, it allows us to keep adding methods similar to this. So what it does is, whatever value whatever method we call, it does the job it's supposed to do. Say it's supposed to do some, add some value to the instance or something, it does that, and then it returns the same class from where it's called. So here, if you see with age, right, what it does is it returns this itself, and this would be the user builder that we were using. So I'll resolve the problem later. Yes. As Shubham Pandey mentioned, it's something like object.method 1.method 2.method 3. It would look something like that. So you can keep adding things like that. So in this case, where you want a user with every value, and where the mandatory fields are first name and last name, you add the first name and last name here. And then you can keep adding methods that will add the value. So if in case you want only with age, you will add with age. And if you want both age and address, you will add with age followed by with address. And then you can add the address here. So something like this. But even with just these methods, you see whatever we are returning, it's still the user builder, right? So we still haven't got the user. So what we'll have is in the builder, we'll have a method which will help us in creating the user. So that would be something like this. So say we have a public, and this method that helps us in building the user, right? It would be returning the type user because it builds and returns the user. So it would be public user. We'll name it build. And then within this method, we'll be passing the user builder. So we pass the user builder. Or no, actually, we don't need to pass it because this would be something that is called from user builder. So we can directly call build and then it would be done. So what we do here is we create a user. So user, wait. So we'll need to use new user, and within the new user, we'll pass whatever all these values that we have stored into the user builder here, right? The first name, last name, age, address, and phone, which were stored here, will pass all these values here. So so this is how it would look like. So it builds the user from the user builder, from whatever value you have passed to the user builder, and then returns the user. So this is how you create it. And these are the things that you have. And now if you look, we won't need any of the other constructors that we created earlier, right? Since we won't need that, we'll only be using this particular, whatever methods we have here. And then along with it, whenever you use this, we'll also call the build so that we get the user as a return value. So what we'll do is, yeah, we won't have these things. And yeah, so the change would be something like, if you have a user, need a user here, you'll add whatever values we need and then call the build. So build makes sure that we get the user. And now if you try to print the user dot something, okay, since yeah, user dot something, what we'll find is, so now I'm just printing the first name. So if I do something like this, we can see that yeah, so if you see, we can see that there is first name like this. And in case you want to see whether the other values were added, just do this.
Plus.
Oh yeah,
Abita.
yes. Yeah, okay, yes. Okay, so if we see, we passed the random value here, which is address. And if you see, we can see both the first name and the address being stored. So if you see, doesn't this make our code more easier? Like we are making use of see something like this. It's like we create a user builder, we pass the mandatory fields, any optional field that we have, we pass it as a, we make use of method chaining, and then we call the methods on the user builder. And then at the end, we make use of the build method that we have in the user builder to get the user that we require. So this is what we do here to make this easier for us. And yes, that's it actually. This is what we do to make cases where building or creating a method, creating an instance is very difficult, easier. So say we have optional or required fields, or even in cases where to create an instance, we need to create instances of many other classes. This is something that we can use. Yes. So if you make use of builder or anything, we separate it into the whole logic of thing, we separate it to a different class, and that class will make sure that everything is created, and it will have a build method or something similar, which will be building the final instance that we require. So in our case, the final instance we require is something of user. So everything we require, we do something like this, and then we do this. So this is what builder pattern actually is. Yeah. So builder pattern, as we mentioned till now, is a pattern which aims to separate the construction of a complex object from its representation, so that the same construction process can create multiple different representations. And this is something which is very useful when we have a lot of number of steps, or there is a complexity due to the large number of arguments or something similar. And so here what we do is we remove the logic related to the object construction from client and abstract it into a separate class. And this class can actually be a separate, like an inner static class, as we showed here in this user. So if we see this user builder that we created, it's a public static class, which is an inner class. Or it can even be a different entire class, which we'll make use of to call this as well. The case where we do that, we'll be making use of an abstract class in the case where we have an entirely different class. But that is only required if the product, if what we require is part of some inheritance or things. So yeah. Moving into the next part, which is the UML for builder. And this here, so director or client, in our case, it's where we need the final product to be created. So if we think about it, it's where we call a create product, which will actually call the builder and then get the product for us. So another thing to point here is builder can actually also have a method, which is like a get product, which can help us in getting the product that we already created again and again. So what it does is it just returns the product that we created earlier again. And here, yes.
Hey, Abita, just to interrupt between. So you mentioned the use case, like when we have to tackle like a constructor overloading, right? Then we will go for the builder pattern. Let's say we don't have a use case of the constructor overloading. Let's say if all the fields are mandatory, we assume. So should we still go with the builder pattern or what?
If the number of arguments is like pretty huge, and like having all of them in a single constructor might be pretty difficult, we can still opt for builder pattern actually, because it makes it easier. We'll know whichever we have added. But then if everything is mandatory, what happens is that with the way we do with these and other things, it might not make sure that everything is there. So with builder, what we did is the builder's constructor itself made sure that all the mandatory things are already there. And then what we did there later is like applied different, had different methods for optional fields. That's what we did in the one here. But as I mentioned here, like, it can also be used when we have a every field is mandatory, but if the object creation is pretty complex, say there is a user in the same user, but if the address was a different class, age was something which took some time, date, and then we had to do a lot of we had to do few things on it to get the age actually, and those things came up. Also, we could make use of build a pattern where we'll pass all those things in a required way. So that's something we can do with build a pattern. Yes.
Yeah,
For
I mean,
both mandatory, when we have all fields as mandatory as well.
yeah, I mean, I saw one use case where we need to pass in a project like 15 or something parameters. So yeah, I mean, let's say if we have a long parameter listing, so to avoid that and give a readability,
Yes.
maybe filter pattern would be good idea.
Yeah. Yes, we can make use of build a pattern actually in that case, where there's a lot of like parameters passed and they are causing some confusion for us as well. Yes. So, yes. So, any other questions till now? Like, if we have anything, we'll take that up and then I'll start with the UML, maybe start again with the UML.
Yeah, I have a question. Why the object creation of user is lazy over here? We can create object in the constructor of user builder.
So if we do something like that, what happens is that we'll have to then later make use of setters, right? Like to later do the assign
Yes.
the values for the other things.
Yes. So in that case, you're saying like only one constructor will be there.
Didn't
For the users class, only one constructor will be there.
Yes.
Okay. Yeah.
Okay. Okay. Yeah. So if you look at this, so I'll start with the UML and explain the things there. So if you look at the UML, we have a director. Director uses the builder to construct the object and also knows the sequence of build product. So in case where here over here, right? If you look over here, this would be what goes into the director actually. So it knows the pattern. So we know that we have to get the builder first. We have to assign whatever values we need then. And then at the end, we have to call the build to get the user. So this is what the director would have. So director would know the flow in which we have to create and all those things. And next thing we have is the builder. So as mentioned, builder would make sure that any mandatory fields that we need are already there. And so in case of the earlier abstract builder that I mentioned, in case you are doing a inheritance and other things, right? That's when we have a builder and a concrete builder. And in that case, builder would be an interface or an abstract class that defines the methods which allows the users to build parts of the objects. And this would also have the method that assembles the final project. So if you see, build is a thing that assembles and gets us a final object, right? So that's one thing. And it may or may not have another method which will return an already built thing. So which is the get product. This get product actually is an optional field in case of builders actually. And concrete builder is where we'll in case an abstract class or interface exists, this is where all the implementation goes to. And this is where we have to make in both we have to make sure that any method that we add is capable of doing method chaining to make it easier at a later point as well. And yes, and this can also keep track of the product it creates, can or may keep track of it. And then the final thing is the product that we require, which is the user in our case. Yeah. Any more clarifications we need here on builder pattern? UML for builder pattern or anything we covered earlier in the previous slides? Yes. Okay. In that case, I'll go ahead and we'll discuss about the next things. So one thing is, if we look at this, it gives us more flexibility instead of having multiple constructors, where we had to pass all the value, like, I had to make sure that we were calling the exactly right constructor, or like we were passing the null for whichever field we were not near, which were not mandatory. Here, this makes sure that those doesn't happen. We have more flexibility here, and it's more readable. And when we say more readable, it's readable as well as more. So, oh, sorry. My Siri opened accidentally. So till where did you folks hear?
We were able to hear you, Abita.
Okay, cool. So here, when we talk about readability or readable code, right? Another thing is that even though we say that it's readable, another thing to notice, it's verbose as well. So to say what the difference between readable and verbose would be, like, readable is when, say, a developer looks at your code and they understand it. But verbose is when even a non-developer looks at your code and understands it. So here, if we see, we're saying we have a user builder, and we say that the user builder we give with age, with address. So it's pretty understandable for anyone, right? Whatever we get has. So if user builder, this passes a first name and last name, it also has age and address, and then we say to build it later. So that's what we mean by verbose actually here. So
Abita, just one more question. Like, why we have created the user builder inside a user?
Usually we go with the user builder as a separate abstract class only if we need to have inheritance, in case if we need to make use of inheritance or other things. So say there is a user, and then we have to create a subclass of it or other things. That's when that's only place when we usually make use of abstract builder classes. Else, the one that we prefer mostly and use is the inner static class if we don't have any inheritance attached with user.
Okay. Yeah.
Oh, also, I forgot to mention something earlier. Yeah, the thing is that another thing we normally do when we create an inner static builder is maybe like make the user a private. So even if it's private, it's something it's accessible inside the inner class, right? So we'll still get it, and we can do something like that as well. Not something mandatory, I guess, but we can do that as well. Yeah.
So, I mean, just one more thing, like in terms of naming convention, you mentioned some of the properties of the users are inherently used by the user builder, right? So can we say a builder only, like user.builder? So user builder is just more like explicitly we are calling inside a user that yeah, we're creating a user builder. So does that make sense?
No, I didn't get you.
So I was just thinking about the naming convention, user builder, right?
Yeah.
So it's explicitly calling out that you're creating object of the user.
Yes.
So because this is a inherent class, right? Static class. Can we say a builder only?
Yes, we can do that. Yes. Yes, we can do that actually. Yes. We can go with user.builder. Yes.
Yeah.
Okay. Yeah. So yeah, when we look at the code that we have here, right? Earlier, when we used to have multiple constructors. Okay, wait. If there are no questions, I'll continue with this point here. So I hope there are no more questions, so I'll continue. So here, if you see, right, compared to the earlier place where we had a lot of constructors, and the number of constructors which would rapidly increase along with the number of optional fields or the fields that we used to have. Here, something to notice that number of lines of code has decreased a lot. Like in the case we saw earlier, we'll have string, first name, last name, everything. We might only have this two. We might have any three, anything like that was possible, right? But compared to that, here, if you see number of lines of code, number of lines of code increased actually. Sorry. Yeah. So see, because we are creating another user builder, which will also have all these fields, and then we have this, and then from wherever we are calling the thing there as well, we have to make sure that to call everything, right, instead of one single constructor that we were calling. So even though the number of lines increase, it has become more the design is more flexible, and it's more readable as well as verbose. Verbose is something which we can say as a con of using builder as well. And the number of lines that increases can also be mentioned as a con. And if we see, when we are using a builder pattern, we are creating a different class just to handle this case of just to have a builder. But in case we were only having this user class and had multiple constructors, we would only be having one class, right? So when we use builder pattern, the number of classes would increase as well. And another thing is that, like mentioned earlier, we don't have to pass any null value for optional parameters. And instance is always initiated in a complete state with whatever values we need. And with this logic, it becomes so that it's an immutable object. And we don't, because we are not using any setters and other things as well. So these are a few things we get to know from this. And making use of chain method calls in builder makes it easier for us as well. But another thing to note in case of chain method calls is that chain method calls may not be a very easy topic for newcomers in Java to understand as well. So that's one pitfall of builder as well. And so earlier we mentioned about factory method, right? And then we are now talking about builder. So to we have seen a lot of places where people kind of find it difficult to understand the difference between builder and factory. So to say what it is, what the difference is, the difference comes in that a builder pattern is like a wrapper on the object, wrapper object around all possible parameters that you want to pass into the constructor. So in our case, it's a wrapper on all the first name, last name, age, address, and phone number. But in case of factory pattern, it's more like a wrapper function on the constructor itself. And builder pattern, what it does is it slowly builds up your parameter list. But in case of factory, it's not like that we pass every parameter we need in the single line, in the single method call or the constructor call. So another easier way, say we have multiple kinds of food, factory pattern helps us to create those different kinds of food. But if we have different flavors of a particular food, or like say in case of pizza, right, the one we mentioned earlier. So the toppings of pizza, it's something that can be optional. So say some people do not need olives. That's something, if we want to have the toppings as an optional thing, we can make use of builder to do it. And either have values for all these optional fields or not, depending on that. Yes. Anything that I should, that we need more clarity on here in builder?
So, Abita, just one question. In
Yes.
terms of unit testing these patterns, how any approach should we take?
This simply helps with the constructor, right? So any field that you have would be as it is, like we don't have to do anything on in that way. Like we make use of it to help with the unit test as well. Yeah. Gunjan, do you have anything to add in this particular question?
How should we unit test? So there is no particular way to unit test as such. You unit test all other codes similar way. You can also unit test this.
Yeah. Yes.
Okay, yeah.
Okay. Okay. Do we have any other questions here? Okay, then yeah. Pitfalls of builder, as we discussed. More classes are involved. Earlier in the case when we only had user, now we have a user and a user builder. And then method chaining, as mentioned, might be a bit complex for newcomers to Java as well. So that's all in builder pattern. Maybe I'll give a homework. So this is like a hypothetical case where to create an aircraft, it involves 3 steps. Basically, the steps involved, we have to create a cockpit first, followed by an engine, and then the wings. And these have to be in us. These 3 steps are the first things that we need. And depending on the aircraft, like whether it's a passenger aircraft or not, we can or may or may not have bathrooms attached to the plane. So this is something that we can that you folks can try out as a homework using the builder pattern to see how it works out. Yeah. Okay, yeah, that's all we have in builder pattern. Any other thing that we want to discuss, anything that we need more clarity here? If everything is good, if you good, you can add a thumbs up. Yeah. Okay, yeah. In that case, yeah, I'll move to the next thing. Yes. One second, yeah. Oh, that's cute. Yeah. So this would be the last topic we'll be covering in this session. So here as well, like in the previous, we'll be going with different requirements and then building on that to find out how to do it in a better format. So the first requirement we have is, as a chocolate factory owner, we want to create a computer control chocolate boiler. What the boiler does is it will take in chocolate and milk, boil them, and then once it's boiled, it passes it to the next phase to create chocolate bars. So that's the requirement we have. So chocolate boiler is what we want to create. So this would be how it might look like in the first place. Oh, wait. Yeah. So we'll have a chocolate boiler. We create it as usual, and then we can call a fill, boil, and drain on the chocolate boiler. And if you want to see the different things that we have inside boiler, we'll have something which tells us whether the boiler is empty or not, and another one which tells whether the whatever is, if it's not empty, it's boiled or not. So that's what we have in Choco boiler in the first place. So this is how the implementation would be. So yeah, this would be what we have initially. We'll have a constructor which will assign the initial value to be true and false, and then we'll have things which would fill it, drain it, and then boil it. Now we have given out a product which does this, and the factory owner is happy with it. But after some time, they come back to us because they somehow made use of multiple chocolate boilers and found that it's difficult to manage them, and wants to make sure that there is only one boiler. So yeah, this is a case where we only need one single boiler. What can be the way in which we may do it? How can we make sure that in whatever product we are given, at any instant, there is only one boiler that exists? Someone was about to say something, yeah.
I didn't understand the question. Can you explain the requirement again?
Okay, yeah. So we have a code which tells us what a a boiler does. So what a boiler does is this, and then the factory owner, whoever was it, they like what we need to do is we don't think in the actual scenario of actual factories, but since just think of this as simply something where we have one computer control thing and whatever happens. Okay, so they create the like say they find it difficult to manage two boilers somehow, and the requirement is like they only want one single boiler at any point of time. So they don't want more than one at any time. They
Okay,
want
just one instance of the boiler, right?
Yes.
Okay.
We have answers in the chat, Abita.
Yes.
Singleton pattern.
Yeah, yes. Yes. So yes, that's the actual thing as well. So what we make use of is something which we call a singleton pattern. And what we do in the singleton pattern is something like this. Second. Yeah. So in the choco boiler that we have, what we'll do is we make sure that there is an instance as well instance as well created of it. And what we need to make sure that is that there is a getter for this instance, which will create the choco boiler only if only if there is no instance that exists. So this is the one thing this is an instance, and this is the only thing we'll have. This would be a private instance which will have a getter for, and the getter would be the thing that makes sure that whether this exists or not, depending on whether it's already there or not. So if we go back to this, yeah. So something we'll have to do is, yeah, 1 second, I'll just move it up. So here, if you look at the code right now, right, this is the constructor we have and it's public. So if we keep the constructor public, what happens is that no matter what we do, at any point of time, we can have multiple instances. So the first thing that we do is like change this into a private thing. So private, make sure that it's not accessible anywhere outside of this, right? And then what we'll do is within the class, we'll create an instance, and then we'll have the instance is the one which will return the instance, and this return would depend on whether the instance already has a value or not. So something of the sort. So if of instance equal to null, yeah. So we are checking whether the instance is already initialized or not. If it's not initialized, what we do is we make sure that it's initialized. So instance equals choco boiler, yeah. And then if it's already there, we simply return the instance that we have. This is because we earlier had a choco boiler here, which was making use of the public constructor. So now, since a constructor is moved out, what we can see is that we'll have to make use of this get instance to get the instance at any point of time. So what we'll do here is also another thing is, since we are making sure, when we create the instance, we make sure that it's a private static instance. And then for the get instance to be available outside of the accessible in outside of the class with the choco boiler class name, what we do is we add the static keyword here as well. So then what we can do here to call the get instance is something like choco boiler dot get instance of So I'll run this code and see, let's see whether they have the same address or not. So earlier, in case when they had different addresses, this one, let's see. So what we do here is here, this would show us the address. So this is from the previous time when we ran it. And if you see here, the last part, right, it says that these are in two different instances because the address varies. And then when we did an equals comparison on it, it returns a false. So now we do the same again with the new get instance that we created. And when we run it, we find that both of them have the same address. And then the equals condition that we were checking also returns a true. So this makes sure that we only have one instance at any time. So that's what singleton how we make sure that there is only one, like one and only one instance at any point of time. But one thing that we, there are two ways actually to have singleton instance. One is to make use of something that we have right now. So this one, what it does is it makes sure that an instance is only created whenever there is a call to the, whenever we need it. So till we don't need it, it won't be created. But there is another way where what happens is that we create the singleton as soon as the class is loaded. So what happens then is we know that there is a instance that is here, right? So what we do is we'll, instead of having this here, something we'll do is along with this one, we'll do this. So what happens is that as soon as a class loads, we also make sure that the boiler instance is created. So this thing, whatever we did right now, is what we call a eager singleton. So eager or early singleton. And the one that we had earlier, which is right now commented out, we were only creating it when we needed it, is something we call a lazy or a singleton or a lazy initialization. Yeah. So now we have seen two different ways of creating singleton, right? But if, okay, so Amya asked whether we can use method chaining in this case as well. Amya, how do you think, like, do you have any idea of how we can use a method chaining? But we should make sure that there is only one instance, right? Or
Yeah,
did you need to make use of method chaining for all these?
yeah. So I was like just talking about all those. Like for each step, there will be one method, so that we can like use that.
Yeah, yes, we can do that actually. The only change we need for making use of here, what we have right now done is to return a void or return nothing, right? But instead, regardless of like, whatever happens, if we do a like return the instance, yeah, or the class, what we can make use of is a method chaining. Like method chaining is not something which is specific to
Builder, yeah, I understand.
yeah, builder. It can be used anywhere we see the, like, find it useful. Yes. Yeah.
Actually, I had a question. Like you said that there are two ways of initializing, that is the lazy and the eager one. So what
Yeah.
is the difference between, like, when do we use the eager and when do we use the lazy?
Yeah. Okay. We'll come to that in the next thing. Okay. So, so what we found here is there are two different ways. One is where as soon as a class loads and one where we need it. So, yes. So if I comment out, I'll just remove this from here. So say this is the code that you have, or you're making use of lazy singleton, right? This is where we'll go to the next requirement, which is like your factory owner, after you made sure that there is only one single instance, what they did is they created another service. say if your chocolate Cadbury is creating dairy milk shots and dairy milk bubbly. So what they did is they for both of these services they made use of this choco boiler get instance, and they have it running in threads. So everyone knows what threads is and what multi-threading is, right? Okay, I don't see any hands raised. So what they do is they want these to run parallelly. So they make sure that there are two services which run parallelly, and somehow they find that when somehow the threads when they're running parallelly creates two instances, even if we do not meant for that to happen. So what happens here is that when we are making use of threading, we are creating two objects, which is because at any point if two threads come up to this get instance and find that it's not null, they go into this choco boiler, this line 15 where we are initializing instance, and then when they return, because two calls were made to new choco boiler, we are getting two different instances, right? So we get two different instances even though they only plan to get one instance. So how can we solve the case where we have a case like this where multi-threading causes it to have something like this happen? Yes. Like Danish mentioned, we can have a synchronized block, or we can have a doubly checked singleton pattern. Yes. Yes. Yeah. And yes, these are things. And then as Aditi asked about one other case where we can to know where to use it. One place where we can make use of eager singleton is also in this case where there is a chance of multi-threading happening and that creating multiple instances even though we do not require for it. So one way is to make use of eager singleton. Another is to make use of something called a synchronized. So what we do in that case is we'll add a synchronized keyword here. So if we only add a synchronized keyword here, what happens is, say two threads come into play. They are both calling get instance at the same time. Since now the method is a synchronized one, what happens is only one of them get access to line 14 and the rest, right? So the first one that gets access creates the boiler and returns the instance. And the second one will only get access after the first one's done. So by the time the second one reaches, instance is already done. So they won't have to do line 15. And so they check here, find that it's not null, and then return the instance. So yes, so that's one way of doing it. Another one was eager singleton. So now another thing that we have is, we know that synchronized is a expensive method. So only if you are sure that this is only required in case of the first call or something, should we even in case of multi-threading, this is the case only when the first time get instance gets called, right? Should we be making use of get instance a synchronized, making sure that only one thread gets access to synchronize get instance at a time? Wouldn't that causes issues? It's an expensive, so it makes sure that the others only get it later. Say it's a very huge project, you have a lot of threads running and all of them are trying to get instance at the same time. They wouldn't get access to it easily, right? So yes, that's a cone of something that can happen if we make use of synchronized in the method level. So there is another way we can make use of synchronized, but that is actually we can make use of synchronized itself to solve it, but through another way. And there are other methods, other things as well that we can think of to do it. So say your project sees that it's not very critical or anything, you can ignore it. But we have to solve it, and we are going to solve it. So how we will do is, as mentioned earlier, eagerly created single instance, singleton or eager singleton. So what happens is that at any point, get instance is called, it's already there. So we don't have to have anything like this. We can directly return the instance which was already created. So that's one thing with eager singleton. Eager singleton is a way to solve it easily. Another method which we make use of is something which was mentioned by Danish, which is doubly checked singleton, or we call it double check locking, the exact thing that we do. So what we do is, we would not make the method a synchronized one, but rather we'll have two checks. We'll check this twice, but between those checks, we make sure that whatever happens is in a synchronized way. So say both of them reach here at the same time in the first case. And the first case is only place where we need synchronized to be happening, right? So both of them reach here at the same time. Oh, wait, sorry. What we do is, after they reach here, we do something like a synchronized off, and then we pass the chocoboiler.class. So we are saying sorry. So we pass the chocoboiler.class here. And then it's within that synchronized that we, so even if we have a synchronized, if we directly place this inside the synchronized, it wouldn't help, right? It still causes the same issue. So what we do is, we'll have a check again inside the synchronized. Once we are inside the synchronized, we'll check again. So this makes sure what it does is, if say like 2 to 3 threads come to get instance at the same time, they find that it's null. They go into line 15. So here, and then they are synchronized. Only one can access the rest of the things at a time. So they are waiting. First one goes in, it's null. So it does the job, initializes it and returns back. And the next one, when it comes up, like when it gets access, it comes here and it finds that instance is already not null. So it will directly just go and return. So same thing. But and anything that any other get instance call that happens at a later point would not be synchronized in this way if we use something called a doubly logged, doubly checked, or double checked locking, or doubly locked singleton pattern, something like that. Yeah. Any questions that we have here? Any clarifications needed in whatever we discussed till now? Okay. Can I get a thumbs up if we are all clear?
Can you elaborate more on line number 14? Like why exactly we are checking there?
Okay. So what we have right now is a lazy singleton, right? Where we only make sure that we create the instance if the instance was not initialized earlier. So this is where the instance is created, right? Like we declare that there is going to be an instance, and this is where we say that, yeah, this is the choco boiler that we need, right? Like line 17 is where we say that choco boiler is created, right? So if we do not have line 14 or line 15, so if we do not have line 14 in case of what happens is that it acts same as what we had when we were using the synchronized method. So here what it does is, like if we make use of synchronizing the method, what happens is that it makes sure that every thread gets access to it one after the other, right? It's the same thing which happens in the if every content inside the get instance goes into the synchronized as well. So what happens is that same as what it literally means the same thing, having a synchronized here and not having this and having the synchronized directly. It's the same thing. So whatever is inside the get instance is again synchronized. But with line 14, what we make sure is that, say it's for the first, first time every method that comes into the get instance, or say when the instance is not initiated, you get two threads that call get instance. That at that point of time, only those two would go into the synchronized here. And say after the instance is created, there are 5 other threads which call get instance at the same time. At line 14 itself, they come to know that it's already created. So they don't have to do any of this. They just have to return the instance here. Did you get that?
Got it. Thank you so much.
Yeah. Okay. Yeah. Any more clarifications we require here? In what we discussed here till now, till doubly it's singleton.
We have like 5 minutes left. So
yeah,
and like we can extend the session by 15 more minutes also, like if you want to cover, but then we can finish it in 15 minutes and take up the questions you have at the end.
Okay.
So
Yeah. Yes. Okay. Cool. Okay. Now something that happens in case of Java and threads is that threads try to make use of the cache that they have. So what they do is, like usually what happens is for anything that's created, they make use of the cache version or the cache memory instead of the main memory and then act on that cache memory. But in case of singleton, what we want is any change that happens at any point to reflect in the other areas as well, right? So if the threads make use of something like the cache, that won't happen, right? Because it's happening in the cache and not in the main part or the main instance that we have, or in this instance, right? So there is a keyword that we can make use of to make sure that threads do not use the cache. Yes. Yes, as Danish mentions again, it's volatile. So what we do is we'll add a volatile here, private volatile static. That's how we add it. So what this volatile keyword tells is that to not use the cache memory, to just make use of the main memory. And then it makes use of that. Yes. So yes, that's what we have in the implementation part of singleton. Any clarifications needed on anything we discussed till here? Cool. Okay, in that case, I'll move to the next part, which would be, yes, this. So as we note from whatever we have done till now, a singleton pattern is a pattern which ensures that we only have one and only one instance at any point of time, and then we have a global access to it. So this get instance is how we have a global access to it. And this is the one and only one instance that we are creating. And yes, when we want only one instance of the class, we change the access of constructor, make it private, and then we have an instance that is initialized. And then this one will only be initialized once, and then make sure anytime you do singleton, like we make sure that multi-threading is also handled. So we discuss the various ways to do that as well. So now UML for singleton. Yes, as we saw, this is a singleton. Whatever we need the singleton for, we create the instance for it, private static one, and then we have a public static get instance method, which will give us access to this instance. So that's what the UML is like. Yes. Yeah. And in inferences of whatever till now we have seen, a singleton it helps us in making sure that we have a control on the number of instances that are there. Here in singleton, it's at most one. So that's what it is. We also have a global access point to the instance. But something that we should make sure of is that singletons are like, your application is using a lot of singletons. We should probably sit back and think about a better design for it, because singleton is something which should be used sparingly. And yes, implementation can be tricky depending on how it is. And another thing is, say in singleton, what you have done is you made your constructor private, right? We make our constructor private. So when we have our constructor as private, there would be issues with subclassing. So we can't extend a class which has a private constructor. And if you change your constructor to a public one, what happens is that the singleton does not work in that case. So, and in that case, we might have to make use of something called a registry and other things, but we won't be discussing all those here. All those things about registry and other things in this session. So yes, that's what we have on inferences. And yes, another thing is last point, or the pitfalls for singleton that we are going to discuss is, since singleton has a global access point and it's available globally, what happens is that it can be used at any part of your application. So it can deceive you about the true dependencies of your code. Say it's needed in a particular place, but if you're making use of a global access point kind of thing, the dependency might not be quite obvious. Another thing is in case of unit testing, where it becomes difficult to mock the instance that is returned by that method. And what happens in that cases, it becomes difficult to unit test, right? And the last 2 points we have is, yes. So in singleton, what happens is that the creation is static and it's held as per the rules of class loader and not that of JVM. So what happens is that what you have may not actually be a singleton in case of OSGIs or like web applications. So what happens is something like, say, you're running a web application in a web container, and your singleton, what happens is that you singleton class is deployed in 2 separate web applications which are running in the same Tomcat instance or something. What happens is at the end you will have 2 singleton instances in that single JVM. So it's like if you are making use of the same container and then running 2 different applications, your singleton might not actually be act like a singleton. So this is a drawback of singleton, but it's tied to a resource which is unique. We should keep in mind that the standard variable means static or one copy as per the class loader. So if you have something you write something of your own to make sure that there is only one, it helps in this case. And yes. So if your singleton has a lot of mutable global state or some global states as in things that change globally all throughout, then we might be misusing the singleton designs powers. Singleton should not be used in those cases. And this is also one main reason that singleton pattern is avoided nowadays, because because of this misuse of singleton pattern, where in case where we need a lot of mutable global states. And having a lot of mutable global states is considered a bad design pattern as well. Design practice, yeah. And yes. So everything that we discussed till now, we discussed about simple factory method, builder pattern, and singleton. So any clarifications we need on any of the patterns that we discussed today? Something that's not added to maybe the PPT or anything which we need to clarifications on, we can take that up. Yes. Okay. I don't see any hands raised or anything. So everything we discussed today, every design pattern we discussed today falls under the category of creational design patterns. Creational design patterns, it, as a name suggests, is a patterns which can help us in the creation mechanism, like helps us in creating loosely coupled or like, things. And it, so basically it's in the, helps in the creation of the objects and instances. So, and these patterns make sure that there is a reuse of code, and then whatever code we have is loosely coupled as well. There are other creational design patterns as well. So to name a few would be, there is abstract factory, there is prototype, and there is also an object pool. So these are some other design patterns, creational design patterns we have. There are other types of design patterns as well. Yes. Yeah, that's it, actually.
That was such a great session, Abita and Gunjan. Like you have clarified a lot of questions as well during the session. So, like we have like floated this feedback link multiple times in the chat. So you can add the feedbacks over there, because it will help, it will appreciate the speakers as well. It will help us to improve these sessions. So it could take some 5 to 10 minutes to fill those feedback. And I'll also add the GitHub link and the slide link in the same Trello board in the resources column. And Abita and Gunjan, do you want to, if you want to take more questions, you can take, and people, if you can extend, you can continue, and then you can ask us questions.
Anything in the doc, Abita or Gunjan, that you want to address? Or
Yeah,
that
I'm
is...
going to the doc now. 1 second.
Sure.
Yeah, there's nothing as such. People are asking for the recording, and yeah, we'll add the GitHub link as well as the recording link.